or would you like to wait a little longer?
It's 12. I think you can. I think you can start, but you may want to give it a minute. One more minute.
Sure. Well, thank you, everyone, for making plans to attend today's Thirsty Thursday webinar. Our speaker today is Jose Colon. He's the Regional Sales Director for the Building and Construction Group at Intertech. His team covers all the territory east of the Rockies. With 22 years of experience in the building products industry, Jose has a widespread understanding of the various requirements that must be met to get a product to market, including the preparation of testing plans through the laboratory testing itself. He participates in many industry associations and events on a continual basis. With more responsibilities in sales and business development now, Jose concentrates on finding new opportunities and making sure Intertech delivers amazing customer service with total quality assured. Jose, I'll let you take it from here.
All right. Thank you, Sarah. Thank you very much. Happy to be here. Thanks to MGA and GNA for holding these webinars. I think it's always good to keep us learning and seeing new things, or reminding ourselves of things we knew about that maybe we haven't looked at lately. So again, my name is Jose Colon. I'm the Regional Sales Director for Intertech, Building and Construction. And today we're going to be talking about building enclosure testing. So here we go. Before we get going, I always start each presentation talking about safety. It's very important to us as a company. So safety is our first and most important core value. Daily, weekly, monthly, etc. Our safety record is good, but we never stop working on it. So just a reminder to everybody on that. Our agenda today. So we're going to talk with 4 different things, really. Why do we test? Why building enclosure testing? We're going to go over the benefits of pre-construction lab mock-up testing, or lab PMU testing. We're going to talk about the keys to success while in the lab, while doing a lab performance pre-construction mock-up. And we're going to briefly talk about field testing. And then at the end, when I'm done, if you have any questions, I'll still be on the call to answer any questions you may have, and I hope I can answer them properly. I'll do my best. So why do we test? There's many reasons, but I'm going to briefly go over a couple of natural events, of course. Rainstorms, earthquakes. We have extreme heat, fire. Maybe I should have added a lava picture on here from Hawaii. It's unfortunate to see what's going on in Hawaii right now. There's not a lot of things you could do about that, but that's another natural event that can happen. Extreme cold. You can see some ice forming. If you don't mind muting the phone, please, I would greatly appreciate that. Maybe it's stopped. Nope, still ringing. Okay, somebody answered this. Nope. All right, so extreme cold is another reason we do these type of tests in the lab. Hailstorms, we see that this time of year in a lot of different places, and of course hurricanes and even tornadoes. Those are some of the natural events that are some of the reasons why we test. And then of course there's some man-made events. Maybe bomb blasts could be natural also, or an accident, but there's more and more times we see them as man-made events. Noise is big, not just because of airplanes, because of highways, New York City, big cities where just the buildings are all right next to each other, and there's trains and there's traffic and there's people and there's fireworks and so forth. More and more the codes are calling for stricter acoustical numbers on all systems being used. So, benefits of pre-construction lab mock-up testing. So Some of the benefits of lab mock-up testing are to make sure that the facade will hold up structurally and also not have any problems with air and water infiltration. It's also a way to make sure the facade can actually be built, sequencing, logistics, and so forth. But of course, we also have to meet building code, contract, and project requirements. That last bullet there is usually why we get called up to give a quote for mock-up testing and so forth. On the right there, you see several mock-ups being tested at some of our labs. I'll try to describe some of these pictures as I go forward. Some of the wall performance characteristics that are looked on for mock-up testing include air and water infiltration, structural performance, of course, for wind load, thermal and condensation evaluations because of temperature, and the weather, building movement, seismic, of course, durability, and some special testing that we've done more and more of, like acoustical testing, hurricane impact resistance testing for hurricane-prone areas, and then, of course, bomb blast testing. Bomb blast testing and acoustical can be done on a separate unit instead of the mock-up. Acoustical, we usually do it on a separate unit for specific size, usually the same unit that's tested for thermal. But we have been asked recently in the past 2 years to do acoustical testing on the mock-up itself, the 2 to 3 story unit with a corner. We have to know that way in advance, and we have to build the chamber differently so we can get a true acoustical reading. When building a lab mock-up, you need to make sure that it's just like what's going to be done in the field. You want to include all the elements that will be used in the real world for the project. That's very important. So now let's go into what some of the keys to success are while you're in the lab. Some of the keys to successes while you're in the lab are selecting the best venue. I will not say anything more about that. Safety and lighting conditions is very important. We have our safety guidelines that you need to follow when going to any of our labs. You see a video. All our technicians have to abide by them, and also the visitors have to abide by them. Lighting conditions are important. We test inside, or labs test inside and outside. So you want to have good lighting conditions where you're testing. Easy access. You want to make sure that you can set up your chamber properly. You have room around the space to work and bring in your equipment and your materials and things like that. Equipment, you got to go to a lab that has the right equipment. Some labs have more equipment than others. The lab might have to rent something specifically for the size or the condition that maybe they weren't ready for, so that happens. And then you have to able to deal with delays. Delays happen. It's not always the lab's fault. It could be weather, it could be failures, it could be material delivery, and so forth. Just those are the main 5 keys to successes for mock-up testing. These are just 2 of the mock-ups. The picture on the left is the largest mock-up we've ever tested. It was close to 60, 70 feet tall. It even included a roof canopy. The picture on the right is just an example of 3 separate mock-ups, just so you can see how they can be installed within proximity to each other, with still room in between for people to work and have space during testing, during construction, and during takedown. Both of those pictures are actually from our facility in West Palm Beach, Florida. You want to understand the project performance requirements relating to the exterior wall. You want to review the test methods required by the project specifications. The basic tests that are called out for mock-ups are usually air, water, both static and dynamic, thermal testing, wind load, static load tests, and then sometimes they add seismic and acoustical and so forth. But the basic ones, air, water, structural. You got to let us know, or we have to see in the spec if there's any special testing requirements like seismic, thermal, condensation resistance, bomb blast, or missile impact, so we can make sure and cover all that. Again, make sure you include an accurate representation of the wall design, inclusive of all typical details. So I think some of the more important ones to make sure that are included in the mock-up for testing are all the different anchoring types that you're going to have in the unit, any support conditions, corner conditions, both inside and outside corners, and then also the longest span from floor to floor. You want to make sure you include that in the mock-up. Sometimes as a lab, clients ask us to quote a mock-up based on a project spec, and they have the drawings, and the architect or the glazing consultant's already told them what to test and what it's going to look like. That's very simple for us to work with. But sometimes you're talking to one of your product manufacturers that, let's say, make skylights, and they want to go into this job to provide their monumental skylights for a mall or a hotel, and they're trying to get ahead of the curve and create their own test plan. Well, we've helped with that also, and we have to look at drawings and elevations and details to pick a section or build a section that will cover what the project is really doing. So it can go both ways on that. You want to allow adequate time in the overall project schedule for approval of pre-test submittals, okay? Mock-up drawings is a very important part of that. So when you send us a project specification with the basic elevation, we provide the lab provides a quote for testing. Then we have our drawings department put together a set of drawings that relate to what the job conditions are for the project to make sure that you're installing into what you're going to see in the field. So the lab usually provides a set of mock-up drawings that you approve before you come and install your system. And these are just two examples of one on the right is just a fairly simple inside-outside corner with a little bit of angle there. And then the one on the left is it's pretty cool looking structure with some slope glazing and some of the facade actually standing, going outward from the wall. So it can get pretty interesting, some of these mock-ups. The formal test procedure is also very important. You want to make sure and have that. Usually that test procedure is part of the specifications for the job, or they're written in another document by the glazing consultant that's been hired for the job. Well, we retype that. We usually put it in our letterhead, and we make sure that it's correct and in the right order, and you have to sign that off before we do any testing. You want to accommodate any special tests in the chamber design. Like I said earlier, acoustical testing has come up on some of the lab mock-ups we're doing, so we want to build the chamber the right way. Seismic movement, interstory drift, and condensation analysis, we need to know all that in advance before we move further. Like I mentioned before, like I mentioned just now, the formal test procedure is very important. It should include any pre-testing, pass-fail criteria, design pressures, and any seismic requirements or any additional testing that's required for the job. We need to make sure it's correct at the very beginning. Placement of the test chamber is very important for both installation and testing. Like I said earlier, all chambers are different. You saw that in the drawing that I showed just now. Make sure you have the necessary equipment to work on your unit, maintain accurate and up-to-date drawings. That's very important from the very beginning through testing. Make sure you have accurate drawings and up to date, and then let us know if anything changes as soon as possible. It's important that the lab knows of any changes as they occur, so that when you come to test, everything's ready and then we're not caught off guard. Prior to testing, make sure that all people working on the project are on the same page. Send out the mock-up schedule in advance. That mock-up schedule should include the installation time of the mock-up, time for visual inspection, sealant cure time for the unit. It should include what the testing duration is being planned to be, remediation and retesting, a report time frame, and then also dismantling. This process can usually, I would say 3 months is how long a unit, from experience, how long a unit will be on our wall from start to finish, from clearing the wall, from building the test chamber that you're going to come install your facade on, to testing, to takedown. It's really a 3-month process. Lately, I've seen some projects that we've done at several of our labs that the developer or the architect or whoever's paying for the job, which can be the glazing contractor, the general contractor, or the developer or the architect, they sometimes have asked us to keep the unit up on our wall for longer periods of time, just as a visual mock-up to see what's going to happen to the colors and things like that. So we can do that also if needed. In addition, prior to testing, you want to create a test plan, but also determine the required observers, who's going to be there. Inform the observers of the schedule for each test sequence. You don't just want to have people sitting around there standing by the test unit when it's going to be a 3-hour setup time for the next test, especially if it's something like a water test or a thermal test. That takes time to set up. So you want to make sure they know what that schedule is going to be. Again, advise all interested parties that schedules will be dynamic. And see, that's me. That was me here. Sorry. Advise all interested parties that schedules will be dynamic. And just know, 90% of all mock-ups require some form of remediation during the test phase. And that's not just because of failures. That could be because they ran a 12 or 15 PSF water infiltration test, and the client wants to go higher just to see if it can meet a higher water design pressure. So, you know, that can happen also. During testing, don't forget these notes. Carefully analyze your test results, please. The cause of premature failures must be determined. You know, it could be excessive glass deflection, glass flaws, anchor failures. Those could be all contributing factors. Make sure you understand the results. You know, make sure you understand what happened. The failure could be workmanship or it could be design. Avoid the temptation of Band-Aid remediation. You know, you just don't want to just keep on adding silicone in certain places or change some things that's going to be drastic to the process, that might be a drastic change to the process that you're going to be using in the field. You want to make sure that whatever change you make is going to work in the field. And of course, during that process of analyzing the results and making any changes, you want to involve the design team, you know, the owner, architect, general contractor, or anybody else that's involved. Very important. Field testing. So why do we do field testing? You know, I just went over some of the keys to success for lab mock-up testing. And so lab testing is performed on prototype specimens to certify or validate product performance ratings or job specifications because the job called for it. Field testing, quality assurance field testing, is performed on newly installed products to verify installed performance of the product and the installation. We've been doing field testing forever, just like mock-up testing, and field testing can be done at one time during construction, or it can be done at 10% of construction, 50%, and 80% of construction. We keep on seeing that more and more in specifications, that field testing is done at several times during construction to make sure that the units are being installed properly. The third type of testing for a project would be forensic testing, of course, it's usually performed on wall assemblies with known water control problems as a means to accurately identify suspect wall construction components and details. Every year we get caught up in cases where some water's coming in where it shouldn't, and we get asked to go in there and investigate. So that's another reason. Okay, reasons to perform field testing. Quality control, of course, is number one. New construction, building facade renovations and improvements, any replacements of windows, usually field testing is required. And then remedial and maintenance verification. That's also another reason. Investigative, I just talked about that. Water leakage analysis on buildings that have been up for a while. I think AMA has a document, AMA 511, that talks about how that should be done. And then, of course, I just talked about litigation reasons for field testing. The most common field tests are for air infiltration or air exfiltration, which is ASTM E783 in the field. Water penetration testing could use ASTM E1105. Those two, air and water, are also called out in specifications like AMA 502 and AMA 503. AMA 501.2 is a very popular test, which is the spray nozzle test, where somebody stands there and just holds the nozzle back and forth. The E1105 is more of a spray rack test with a chamber on the inside. Lately, more and more, we've been asked to do dynamic water testing in the field, which is AMA 501.1. That's usually done on a mock-up with a fan, an airplane engine. We also have some smaller devices that we can take in the field. I think I had a picture of it right there. There's one of our wind devices that we take on the field. So the good thing about using that device in the field is that you don't need a chamber on the inside of the unit, and you can test more units at a time. And it's applying wind, it's a dynamic wind while spraying water at the same time. So more and more they're asking for 501.1 in the field also. Other common field tests are structural performance testing, and then there's some specialty field tests like acoustical. Acoustical has been a huge growing field in the industry for acoustical field testing. Thermal evaluations, glass evaluations, we get called for that, for job site inspections for bow, warp, and frost point, and so forth. Masonry anchor, shear and tension tests, masonry wall absorption, tracer smoke. Another big one that we're doing a lot more is blower door. Whole building air testing is also a type of test that we're doing more and more, specifically in the Northwest. A lot of the states have requirements for whole building air testing. And then, of course, roof testing. We do a lot of testing on roofing products. That concludes my presentation on building enclosure testing. I'm up to 20-something minutes. I think I did okay. Thank you very much. Does anybody have any questions? Oh, right. Or maybe I lost everybody and I've been talking to myself. Sarah, are you there?
I'm here, yes. All right. Well, if there are no questions, I'm sure Jose wouldn't mind if you reached out to him directly. And otherwise, thank you for attending. We did record this webinar, so we will be placing it on the glasswebsite.com member portal in a matter of a week or two. So you can look for it there as well if you need to.
Give a call on 101. Jack, give us on 101.
If you need
All
to
right.
revisit anything that Jose presented. So thank you very much, Jose, for making the time to present this today.
All right, Sarah. Thank you, everybody. Have a good day.
You too.
Bye-bye.
Bye-bye.